What if I tell you that your research papers are ignored for a decade? You discover something, but someone else takes the credit. Despite receiving a position, you are totally thrown out of the picture. Mendel and Darwin are those names which are present almost every time in biology textbook. But there were also some scientists who did an incredible job, but their names were never written or completely detailed. Their faces remain behind the curtains. So in today's video, I'm gonna raise the curtains to show you those faces. Hidden scientists in biology history. In its part 1, the stolen stories. Whenever we talk about the structure of DNA, its helical structure, the credit goes to James Watson and Francis Crick, for which they were given a Nobel Prize in 1962. Yay! But what if I tell you that Francis Crick and James Watson were the bloody thieves? This is the picture right on your screen. Is called Photo 51. It was stolen by James Watson with the help of Morris Wilkin, but without the permission of its real owner, the Dark Lady of DNA, Rosalind Franklin. Born in 1920 to an influential British Jewish family, Franklin was a prodigy in physical chemistry. She was a world expert in the structure of coal and carbon, which actually helped British efforts in World War II. Later, she moved to Paris in order to learn X-ray crystallography, a method which was used to determine the structure of a molecule by beaming an X-ray through and analyzing the diffraction patterns. In 1951, she joins King's College London at a time when the structure of DNA was a mystery. While her colleague Morris Wilkin was far away, Rosalind Franklin and one of her students, Randall Gosling, was able to produce Photo 51. Let me explain you how. Franklin fired an X-rays on a strands of DNA molecule. Its atom is scattered through the rays, heating the photographic film, creating a pattern of spots. To an untrained eyes, this was just a diffraction pattern, but to a crystallographer, it was a mathematical map. The most striking feature of this Photo 51 was its X-shaped pattern. In the world of X-ray crystallography, a helix always produces an X-shaped diffraction pattern. And if the DNA would have a different structure, like linear or circular, this diffraction pattern would be completely different or something else. Secondly, if you look very closely towards the ends of an arm, there are some missing smudges which are very faintly visible. These are called smoking guns, and these are produced because of a process called destructive interference. And destructive interference is only possible when there are two strands wrapping around each other. So this proves that DNA is not a helix but actually a double helix. Lastly, she was able to calculate the distance between top and the bottom of the arm, that is the one strand, and she determined the length of a one strand 3.4 nanometer long. Until now, we came to know about that DNA is a helical structure, and exactly it's not a helix but a double helix. And one strand of a DNA is 3.4 nanometer long, which actually reveals that how tightly these two strands are wrapping around each other. And this was only possible because of a single photograph for Photo 51, which was produced by Rosalind Franklin and her student Randall Gosling. So, what was the role of the two men, James Watson and Francis Crick? I do not understand. And I think so that you are also asking the same question behind the screen. So let me explain. This Photo 51 was handed over to James Watson by Morris Wilkin, and now this Photo 51 was in the hand of James Watson. So he immediately recognizes this X-shaped pattern and predicts a DNA to be a helical structure. Both James Watson and Francis Crick used Franklin's data from an unpublished report and create an imaginative structure of DNA using. Their work was lit in 1953 Nature journal. whereas Franklin's work were put below the heavy papers. To an audience, it just looked like the real discovery was made by James Watson and Francis Crick, whereas Rosalind Franklin has just confirmed their theory right, rather than providing a blueprint for it. The second story takes us to 90s, when the scientific world was so obsessed with the riddle that how is a biological sex determined? The prevailing theories were not based on biologies but were just the guessworks. The mother's diet, temperature of an egg, or even a divine will. To the people of now our generation, it completely sounds like rubbish because almost every one of us knows that it's genetics. It's whether Y or X chromosomes which determines the sex of the person. But do you know who made the discovery of it? Some might say Thomas Hunt Morgan. So you are correct, but not completely correct. The actual name is Nettie Mary Stevin. Before she ever changed the foundation of modern genetics, Nettie Mary Stevin was a teacher in rural Vermont. Born in 1961, she lived a quite scholarly life for decades. But at the age of 39, the traditional path wasn't enough. This is the age where most of the women are retired from an academic pursuits. But Stevin enters Mary College. She wasn't just a student, but a woman obsessed with the mechanics of life itself. While it was a German biologist, Hermann Haken, who physically absorbed an unusual structure in firework in 1891, but he could not grasp its purpose. It was Nettie Stevin who actually solved this puzzle. By studying mealworms, Tanavideo monitor, she spotted something which no one else had. She observed that a female mealworm is having 20 chromosomes, whereas male mealworm is having 19 large ones and another one was significantly smaller. She correctly identifies X and Y chromosomes, concluding that presence or absence of X and Y chromosomes is actually a master switch for biological sex. In 1905, Stevin published her definitive 75-page monograph. Simultaneously, the famous Edward Wilson published his own paper. While Wilson remained hesitant, still entertaining the ever-mental theories, Stevin was absolute. Yet, because Wilson was a big name, the discovery labeled as the Stevin-Wilson theory. Over a time, Wilson's name grew in history books, and Stevin was quietly pushed into the footnotes. For nearly 80 years, she was a lost scientist. Textbooks credited Thomas Hunt Morgan with the discovery, a feat for which he later won Nobel Prize. But the truth has the way of its surfacing. Morgan himself eventually admitted in a memorial for her that Stevin had a share in a great discovery, raising her precisions. Today, we know the truth. If you were taught that the father determines the sex of a baby, you were learning the Stevin's theory, even if her name wasn't on the page. DNA can move inside your body. This statement is hard to believe. You're probably laughing or calling me mad behind the screens. Well, don't feel bad. That's exactly what the world's top scientists did to Barbara and McClintock for 30 years. While the world was distracted by World War II, Barbara was a step away at Cold Spring Harbor Laboratory. In 1944, she began her most intense research on mange, bone. By 1948, she noticed something impossible, two genetic locus, which she named as AC and DS. They were physically unlinking themselves and jumping to new positions on the chromosomes. This was her eureka moment, the discovery of transposable elements. In 1951, she finally walked onto the stage at the Cold Spring Harbor symposium to repeat her findings. She expected excitement, instead got a stony silence. The men in a room called her work incomprehensible and anecdotal. They believed the genome was fixed, rigid blueprint. To them, Barbara wasn't just pioneer. She was just a woman talking about jumping bone. The rejection was so cold that Barbara made a heartbreaking decision. She stopped publishing her results. Instead, she stayed in her lab, continuing her research in secret while the rest of the world caught up. It wasn't until late 1970s that a molecular biology finally developed the tools to see what Barbara had seen decades earlier. In 1983, nearly 40 years after her initial discovery, the world finally apologized. At the age of 81, she was awarded a Nobel Prize in Physiology and Medicine. She remains the only woman to ever win that prize unshared. In all three stories, the one thing was common. Rosalind Franklin did not got recognition because of her male contemporaries. Morris Wilkin, one of her colleagues, did not wanted a woman to get recognition, name or fame for the new discovery. James Watson, in his book The Double Helix, famously portrayed Rosalind Franklin as Rosie, an unimaginative and belligerent woman. But in reality, she was intelligent and rigorous scientist, only demanding for a professional respect. A woman is always thought to be working as a lab assistant or in her laboratories, and it cannot be accepted when she discovers something big. That was the story of Lady Mary's death, where Edwin Wilson, Thomas Hunt Morgan was having a big name and fame got recognition, whereas Lady Mary Steven's name were pushed into a footnotes. Lastly, a woman also cannot be accepted with something unique idea, with something new to discover, with something new proposals, because a woman cannot be always correct. That is the thought of most of the men in a male-dominated society, which we have seen in the story of Barbara and McClintock. It was a time when a woman working with the minimal protections were discouraged. Take for example Rosalind Franklin, who gave us the structure in 1952. She died of an ovarian cancer in 1958 at the age of 37. The another one, Lady Mary Steven, gave us our identity in 1905. She died of an ovarian cancer at the age of 50. And thankfully, that Barbara and McClintock got recognition. She gave us the engine of her life in 1944. These stories weren't just lost. They were sidelined by the world that wasn't ready to listen to women's voice anymore. But today, we are putting their names back where they belong. Which of these legends do you think was wrong the most? Let us discuss in the comments.